Hello everyone. Today I'm going to discuss with you the parts of the microscope. Okay, this is a usual microscope that is present in our setup, laboratory setup. So this is a binocular microscope that you can just see. There are two eyepieces over here. Okay, so this is a binocular compound microscope, and its full name is Brightfield Compound Binocular Microscope. Okay, so I'm going to discuss about the parts of this microscope today. Okay, the parts and which parts are placed where and how to handle this microscope while doing the experiment. Okay, so first and foremost, this is a compound microscope with the power source which is attached to the back. Okay, I can connect it with power sweeping plug. Okay, and at the back end of this microscope you can see the power switch is given over here. Okay, I can switch it on. Now I can it is already on, so these are the switch which switches it on and on, off. Okay, this is the off, this is the on, off, on. Okay, so I can just switch it on and off by this switch. Okay, the power cords are at the back. So this microscope, this compound microscope, the part of the microscope is studied under four categories. Okay, those are the supporting system, okay, which supports this framework. Okay, we have an illuminating system, which is obviously the part which illuminates the structure. The magnifying system, obviously the microscope work is to magnify the structures that we are sliced, that we are going to prepare and place it. Okay, so this is the part where the magnifying system is located, and we have another part called as the adjusting system. Okay, so one by one, let's study what are the parts, where are the parts kept. Okay, now the word supporting means it supports. Okay, obviously the part of the microscope which supports the whole framework. Okay, so this horseshoe shaped or U-shaped structure that you can see at the very bottom end is called as the base of the microscope. If you tilt it, then you can see the rubber cups are attached at the three ends so that you can firmly place it on the platform. Okay, so that it doesn't move here and there. Okay, while you're working with the microscope. Okay, this horseshoe shaped base structure, metallic structure, okay, houses the power cord, plugging in point and on off switch. Along with that, it has at the back end in this particular framework we have the regulator for the illumination. Okay, this is the regulator for illuminating system. Okay, so these are the three part, the part of the base. And what now along with that base we have, if we can move at the back, first of all the microscope wherever you are handling, so this is the place where you will be sitting. Okay, and you will be observing. So this is obviously the anterior part. Okay, this part of the microscope is the called as the anterior part of the microscope, and this is the posterior part, or you can say this is the front part of the microscope and this is the back part of the microscope. Okay, at the back part of the microscope you can see the power cords are attached and the switches are there, and the front part of the microscope the illuminator system is attached. Okay, now just look closely at the back end of the base. A perpendicular pillar, a perpendicular frame structure has come. Okay, this is called as the pillar of the microscope. Okay, so this pillar, as you go up, this pillar is attached to a C-arm shaped structure. This is called as C-arm of the, or C-arm handle of the microscope. This falls under the supporting structure of the framework. So this use of this free arm is to hold the microscope with your non-dominant hand and with the dominant hand, and supporting the base with the other hand. Okay, so this C arm is used to hold the microscope firmly. Okay, while you are moving here and there with the microscope. Okay, so along with that, sometimes it is also discussed that body tube, a term called as a body tube, is discussed under the supporting framework of the microscope. Now what is this body tube? You can see this more or less cylindrical structure starting from your eyepiece and ending at this is called as the, by the way, called as the objective. I will tell you what, how many types of objectives are there and what type of objective is this. Okay, so basically this roughly cylindrical structure you can see starting from the eyepiece and ending at the objective. This is the body tube. This is also how been discussed under the supporting framework structure of this microscope. Okay, along with this, revolving nose piece is discussed as the part of the body tube. Okay, the revolving nose piece, this looks like a nose end, okay, nose end of the body tube, okay. Along with that, you can see just to the front of this pillar, another metallic structure is passing in the front, okay. Um, More or less square frame structure, okay. This is called as the stage of the microscope, okay. Now thing is that this also falls under the supporting frame structure of the microscope, okay. Now this stage of the microscope is the place where we put our testing glass slides, okay. Whatever smears we make to examine, we can place it over here, okay. So obviously there has to be some aperture at the very center of the stage, okay. If I can move the stage, okay. So here you can see at the very center we have a hole or aperture through which the light passes from the artificial source of light, okay. So this first is that this black colored metallic structure placed above or in front of the pillar is called as the stage, and this stage is of two types, okay. Now this stage movement can be controlled by a regulator placed at the right side of the examiner, okay, or the technician. So you can see this part, this regulator, it helps in moving the stage front and back, right. Now as you can see, you are moving front and back. A part of the stage is moving forward and a part is left behind. The part which is fixed, it's called as the fixed stage, okay. This part is called as the fixed stage, okay. And the part which I can move forward and backward is called as the mechanical stage, okay. So mechanical is moving, so that's why it's called as mechanical stage, okay. Then on the top part of the stage, mechanical stage, you can see a spring action clip is there. Now this spring action clip is used to hold firmly the glass slides that we place, okay. Along with that, you can see this screw at the bottom part of this adjusting screw or regulating screw of the stage. You can see another screw is there which helps in moving the spring clip left and right, okay. So this screw, part of the screw helps in moving the stage forward and backward, and part of the screw helps in moving it left and right, okay. And you can also see some caliper markings are there. So these are called caliper scales, okay. These caliper scales are not used by academician, but those who are doing the screening examinations, the pathologists and the microbiologists, if they have to pinpoint structure that they have um, figured out, and if they want to repeat the examination on that particular point, they can just easily coordinate the point, okay. They can say it has to be like 130 mm in x-axis and y-axis is 40 mm, then they can pinpoint the area where the structure is there, okay. These are not needed in academic point of view, okay. So all these parts that I have discussed right now, all these falls under the supporting frame structure or supporting system of the compound microscope that we are dealing with, okay. Let's recapitulate. The base of the microscope, the pillar of the microscope, this is the pillar of the microscope, this is the C-arm of the microscope which is used to hold the microscope. This is the body tube starting from the eyepiece to the tip of your objective. Along with that, this is the revolving nose piece which houses the objective. Then just perpendicular to this pillar we have this structure which is called as the stage, okay. These all falls under the supporting system of the microscope. Now let's discuss about the illuminating system of the microscope. Now illuminating, the word means it illuminates the microscope, okay. So obviously the artificial source of light that is present in the interior or the front part of the base where the illumination artificial source of light is there. Now so trivial question is that this what kind of a bulb is there, okay. This bulb houses a tungsten filament, okay. So it emits white diffuse light, okay. So we can regulate the intensity of the light with the help of this regulator, okay. Then in this illuminating system we have another structure which is discussed under the illuminating system is this. just at the bottom part of the stage, you can see uh, more or less cylindrical structure I can move with the help of this regulator. Okay, so the left part of the examiner, another circular screw is there which is helping us to move this cylindrical structure up and down. So this is called as the condenser diaphragm system, which is discussed under the illuminating system of the microscope. Okay, now this condenser diaphragm system, if you look closely, if I just tilt it, okay, see, it's made of two words, right? Condenser and diaphragm. So one part is called as the condenser, another part is called as the diaphragm. So if you look closely, so there is another screw. Okay, not this one, this one. Okay, let me see. Okay, yeah, if I'm able to, yeah, see, this is a regulator for the diaphragm or the iris. Okay, just like your iris of your eye, it can also close in and open up by the help of this lever. Okay, so the part which is opening and closing, you can see it is the only part of the cylindrical structure which is called as the diaphragm or the iris, and the rest of the part of the cylindrical system is called as the condenser. Actually, the condenser is nothing but convex lens which actually condenses the light which is coming out from this artificial source of light towards this stage. Okay, it condenses light, converges its light. So in some microscope it's used AB type of condenser. Okay, some other types are also present, so it's not necessary. So knowing the part which is present or considered under illuminating is it should be discussed. Okay, now let's go forward. Okay, now let's discuss about the magnifying system. Okay, in the magnifying system, the eyepiece, the objective, okay, the optical tube is discussed. Okay, the part of the microscope which is actually helping us to magnify the image object. Sorry. Okay, so you can see in the magnifying system there are two eyepieces, so that's why it's called as the binocular lens. Okay, and we have in this particular bright field compound microscope we have one, two, three, four cylindrical structures at the end of this body tube which are called as the objective. So easy way to remember is that this is the object that we are going to examine. So the lens which is nearer to the object is called as the objective, and from here you are going to see, all right? So this is the point at which your eye will be there. So this is called as the eyepiece of the lens of the microscope, right? Now closely examining this, you can see this objective I am able to move, I can revolve. Okay, and also this objective is placed on a circular platform which is revolving and it looks more or less like a nose. It looks more or less like a nose, so it's called the nose piece, revolving nose piece of the microscope. Okay, so as I'm moving you can hear a clicking sound appears. Okay, just when the clicking sound appears, that means it is that point which directly coincides with the principal axis of the convex lens that is placed inside this objective. Okay, if it doesn't clicks, that means the lens didn't arrive at its recommended slots. Okay, if it is not coming at the slot, then no ray of light will be passing from the objective towards the eyepiece. Okay, so this is the objective. So as also you can see the objectives are of various length. Okay, this is the shortest one and this is the longest one. Okay, and also you can see the lenses are been painted with some colors, right? The shorter one, objective lens is power is 4x. It magnifies the object 4 times. Okay, and it's painted red color. Little bit longer than this is the 10x power. Okay, it's little bit longer than 4x and it painted with yellow color paint. Okay, little bit longer than this 10x is called as the 40x power. So it magnifies the object 40 times and it's painted blue in color. Okay, and the longest one objective lens is power is 100x. Okay, it is also called as the oil immersion lens and is painted a white band. Okay, also you can make out the power by just looking closely at the numbers that is written on the body of the objective. You can see there is written 100 oblique 1.25 oil. Okay, 160 divided by 0. So 17, these are all the focal lengths and all the spectrum optometric values of the glass, convex glass lens that is being made. It's not needed. What we have to focus on is the number that is written before the flash, or that is written in bold letters. There is 100, so that means it is a 100 power lens. Okay, here it is written 40, that means it is 40 power lens. So that's how you can make out which lens are what power. Okay, then coming forward, these are the eyepieces. Now these eyepieces are 2 in number, okay, and both of these eyepieces have the same power that is written also. You can just remove this eyepiece and just check the number. Okay, this is written as there. Okay, so 10x, that means its power is 10 times. Okay, it magnifies the system 10 times. Okay, along with that, another important point I want to mention is that along with this lens, there is eyepiece and the objective, we also have a prism in this particular body tube, okay, which bifurcates the light that is coming up into 2 slots, and so that the ray of light has passed equally in both of the eyepieces. Okay, otherwise there would have been a single beam of light that is coming out, right? So it is bifurcated. So there, along with this complexity of having 2 eyepiece and 4 objective lens, we also have a prism, and that makes, along with that, the artificial source of light makes this whole microscope the name as compound. Okay, now I was also telling about the optical tube length. Now I've told you the body tube length, it starts from the tip of this eyepiece to the end of the, or the tip of the objective. This is called as the body tube. Okay, its measurement is approximately 17 to 18 centimeter. Okay, there is another terminology called as optical tube length. Optical tube length is nothing but the length from the focal point, the far focal point of one convex lens to the far focal point of the other convex lens. So here there is one objective lens, one convex lens, so it has a far focal length somewhere around here. Okay, and this is the objective lens. Okay, it has another convex lens. Okay, so it will have a far focal length somewhere around here, imaginary point. Okay, if you take the distance from this point to this imaginary distance, it will be around 25 centimeter to 30 centimeter. That is called as the optical tube length, and that's the difference between body tube length and the optical tube length, right? Another important thing is that everyone has that, every compound microscope nowadays is being given binocular compound microscope with some adjusting screws. Okay, we can adjust the eyepiece based upon your interpupillary distance. Okay, everyone has this unique interpupillary distance, the distance between the 2 pupils of your eye. So you can have to adjust it so that your vision that comes, it comes as a binocular vision, and you don't have to strain your eyes while observing the structures. Okay, so that what I have discussed till now is called as, this falls under the magnifying system. Now another important formula that you have to know while discussing about the magnification system is that what is the magnification of this particular microscope. As I told you, the least power of the objective is 4x, right? 4x, and the maximum power is the 100x objective length. Okay, so we can, and also in the eyepiece the power is the unique one power, that is the 10x in this case. Okay, we have also another variations like as a 5x or 4x or whatever. Okay, so the formula for magnification is multiplying the power of the eyepiece by the multiplying the objective powers, objective lens power. So if I'm using the least power objective lens and keeping the eyepiece power same, supposedly I'm keeping it 10x eyepiece. So now at the least objective power, the power magnification of this microscope becomes 4 into 10. That means 40 times you can magnify in this particular settings. Okay. Now, if I'm keeping it in a 100x setting, now the magnification of the microscope becomes 10 into 100. That is 1000. So this microscope has a capacity of magnifying the object from 40 times to 1000 times. Okay. Now, while using the low power settings, we have to also, and high power settings, we have to adjust this image. Okay, adjust the stage and this body tube. Okay, so how do we adjust? There are some adjusting system of this microscope. What are the adjusting? First and foremost adjusting system is this. the regulator which regulates the light intensity that is coming from the artificial source of light. Second adjusters are the this. On the either side of the pillar you can see a circular screws are there, one a bigger and a smaller. And also you can observe that while I'm moving this screw, the other screw also automatically moves. So that's very convenient for you, so that if you're trying to adjust the microscope with one hand, your other hand becomes free to do other stuff like other work like adjusting the stage, okay, or moving the slot of the objective lens, okay, your other hands are free, okay. Now these are the positions, these are the adjusting screw. Also along with that we have an adjuster screw for adjusting the position of the condenser diaphragm system. So this is the condenser diaphragm screw. We have another adjuster which adjusts the position of the stage, okay, and the slide. Okay, these are the adjusting system of the microscope, right? These are all the parts of the microscope that I have talked. Okay, now let's recapitulate. First part of the microscope is the supporting system. Okay, the horseshoe shaped base. Okay, then we have the pillar. This is the pillar of the microscope. Then we have the C arm of the microscope, which is actually used to hold the microscope like this. Okay, like this. Then we have the body tube. This is the body tube of the microscope. Okay. Then we have perpendicularly from the moving forward from the pillar, we have this stage. All this falls under the supporting structure. Then we have the illuminating, which is nothing but the tungsten bulb here. Then the condenser diaphragm system, okay, which is the diaphragm. This is the diaphragm, okay, of membrane kind of a thing is closing off and opening, or this is the diaphragm, okay. Then we have the magnifying system, that is the eyepiece objective, okay, with a revolving nose piece. Then we have the adjusting system, that is the adjusting screws that are present in the microscope. This is the light adjusting screw. Then we have the force adjusting screw, and this is the fine adjusting screw, okay. Then we have a condenser adjusting screw, and we have a mechanical stage and slide adjusting screw, okay. Okay, now these were all the parts of the microscope. Now let's discuss about what are the probable positions of the condenser, okay, diaphragm position in case of the power of the lenses that we are using. Supposedly we are using the 44. Let's discuss about the 10x, okay. Let's supposedly using the 10x objective lens for the examination, okay. So this is considered as a low power lens, okay. So this low power lens, when it's placed on its position, the position of the condenser should be at the lowest position, at the lowest possible position you can bring it, okay. And the diaphragm can be opened at the least possible position. How to know at what point it is opening or not? See, observe at the top part of the stage, the light is emitting, okay, from the artificial source of light passing through the condenser diaphragm system, then it's passing through the central aperture of the stage, okay. The light, when I regulate, see, it is completed. Now I have completely opened the diaphragm. It is, the light is completely illuminated, okay, the stage is completely illuminated. Now I have completely closed it, okay. So when you are using 4x, the condenser should be at the bottommost position and the lever should be partially open, so that a kind of a pinhole light is coming up or appearing from the center of the stage, okay. Now this is the point at which you should know the principle of working distance, okay. The principle of working distance means it's the distance between the glass slide and the tip of the objective lens, okay. Now for every power objective lens, approximately these are the distance, working distance, that has to be kept in mind. In case of your low power objective lens, the working distance should be 5 millimeter to 50 millimeter. That means it could be like the thickness of your finger. Okay, if I place it like this, the distance between the gap between the glass slide and the tip of the cover slip, sorry, objective should be like this. Okay, you might have to do some adjustment with the help of the fine and the coarse adjustment screw. Okay, to bring in another focus. Okay, while you are using the oil immersion, what are the positions? Let's bring the oil immersion into, this is called as the oil immersion lens 100x. When you're bringing the 100x lens into position, the condenser should be at the topmost position as possible. You bring the condenser at the topmost position and you fully open the iris as full as op. This is the recommended position based upon your vision, your feasibility. You can just do minor adjustments, okay, but these are the, whatever I'm giving you, these are the guidelines of using the microscope, right? Then this working distance now decreases from 5 millimeter to 0.15 to 1.5 millimeter. That is, it is absolutely close to the objective lens, sorry, so glass slide. Okay, so almost touching, but there will be some potential space of 0.1 millimeter. So that's why this space can be hindrance for our clarity of vision. So what we do while we are using the oil immersion, we use a specialized solution called as the cedarwood oil or liquid paraffin, and we place it on the glass slide and when touch the tip of the oil immersion lens on this solution, so that what happens, we know the principle of optics. When ray of light passes from the darker denser medium to a lighter medium, it has to deviate. Okay, so there will be like decreased resolution of the object that we are trying to see. So cedarwood oil has a equal refractive index to that of the glass. Okay, so when I place cedarwood oil, practically a uniform refractive index is being created by this glass slide, the cedarwood oil, and the glass material of the objective lens. So minimum amount of refractions are there, and we can observe the structures very clearly. Okay. In case of the 40x, what happens? This is actually at the very middle, no, in between 10x and the 100x. So what we'll do, we will bring the condenser at the middle position and we will open the your iris at the mid position, and the working distance will also be at the mid position. Okay, and you have to do some minor adjustments with the help of the fine adjustment and the coarse adjustment, and you will be able to visualize. Okay, so that's the whole funda or concept behind the parts of the microscope, specifically this dark field binocular compound microscope and the working principles behind it. Okay, thank you.